Uniform rod of mass m and L is pivoted at the one of its ends so that it can rotate in a vertical plane. So it is a pivoted about this end, and there is a negligible friction. The free end is held vertically. शुरू में इस जगह है, and then released. The angular acceleration of the rod when it makes angle theta. Then we know torque. Torque is equal to I alpha. So we can say it is a torque. In this given situation, torque is equal to, due to weight. The weight is mg. Weight is mg means mg multiplied by perpendicular distance from the pivoted end, and that distance is this angle is theta. Center of mass to the pivoted end is L by 2, so it is L by 2 sine theta. Therefore torque is equal to mg L by 2 sine theta. And we know moment of inertia about one of its end is ml square by 3. So alpha equal to torque divided by I. That's why it is mg L by 2 sine theta divided by ml square by 3. Then it is alpha equal to 3g by 2l sine theta. So correct option is a third one. Next question, it is a mass of the block is a 1 kilogram, radius is a 1 meter, and when it is released from the rest, it falls through a height of 2 meter in a 1 second. So height means 2 meter in the 1 second. So we can say S start from rest, S equal to half at square. A is the acceleration of the block. Then S is a 2 meter in a 1 second. So 2 meter in a 1 second is equal to half into A into 1. A equal to 4 meter per second square. That's why the acceleration of the block is a 4 meter per second square. The weight is a mg and the tension is a T. Therefore torque on this mass on the wheel is a T into R. So first of all, force equation of the M is a mg minus T is equal to ma. A is a 4, and second torque for the wheel, it is a T into R is equal to I alpha, and I is a given. I निकालना, I calculate करना, I into alpha equal to A by R, it is 4 by R. So according second equation, the P equal to 4I divided by R square, and we know R square, R is a 1, so R square is a 1. Simply T equal to 4I in the second equation. The weight of the block is a 1 kg, so it is 10 minus T equal to 4 and T equal to 4I. Then we 10 equal to 4 plus 4I. Then we can say 4I equal to 6 and I equal to 4. 6 by 4 means 3 by 2, it is 1.5 kilogram meter square, and that is a 1.5 is the third option is correct. Circular platform mounted on a frictionless axle. Its radius is given, it is 2 meter, and moment of inertia is also given. Initially it is at rest, and 70 kilogram stands on the ease. So it means suppose the upper view of the disc is this one. Man is moving, suppose clockwise or anti-clockwise, but the given speed is with respect to ground. So suppose it is anti-clockwise, means mass of the man, velocity of the man, and radius of the platform, that is equal to I omega of the platform with respect to ground. Mass of the man is a 70 and velocity is given, it is 1, and radius is 2 meter, and the moment of inertia of the platform is at 200. that is multiplied by omega. Then omega of the platform with respect to ground is a 140 divided by 200. So it is a 0.7 radian per second. Correct option is a fourth one. In this, it is a case of impure rolling. In this, a solid sphere of mass m is placed on the rough inclined plane, and the coefficient of friction is a mu. It is not sufficient. It is not sufficient for the pure rolling. The center of the sphere slides from the rest, and its kinetic energy become k. And according work energy theorem, the change in kinetic energy is equal to work done by gravity as well as work done by friction. Then change in kinetic energy is a k, start from rest to k. Then work done by gravity, so the vertical height is this angle is theta, then this is L sine theta. Then work done by gravity is a mgl sine theta plus work done by friction. Then we know work done by friction is equal to k minus of mgl sine theta. That is difference of the k and mgl sine theta. So the minus mgl. So the correct option is the second one.